Yo, what's up, everyone? So first things first, I'm sorry about the slight delay on this worksheet. Um, I had technical difficulties yet again, but I mean, that's just how online school works. Basically, I updated my Mac to the new software, but it screwed up the software I use to make my videos through my document camera. Um, so I figured that out last night, and then it took me until this morning to realize that I could do a Zoom call by myself and record it, and that would still connect the two things. So I figured that out, but the quality is pretty crappy. I can't even really zoom in or zoom out, or it messes up. And I don't think you can see it as well. But for this week, it's fine, and I'll figure out a solution moving forward. So I'm not that worried, and I appreciate you for rolling with the punches as far as it being delayed. Now, this worksheet is really important. First, this is the only mandatory assignment of this week, and it is the most important assignment for reviewing for our test. So I'm going to give you two review sets, review set 1 and 2, and then I'm going to give you a test on Thursday, and it's going to cover quadratics, which we've done for a long time, okay? And what we know is that graphing covers every single component of this unit, because the main thing is, factoring, completing the square, figuring out how we can make the shape from that. So this review set is going to be really long, but it's going to cover every single thing that could be on the test. Okay. Then when I do review set 2, which I'll give you later in the week, that's going to be optional. Okay. And we'll just cover the factoring and all of that, like a little bit more in detail to make sure we're all set on what I think is the hardest skill. But review set 2 is going to be optional. And this set, which actually does cover slightly new stuff, and I'll tell you that, is going to be mandatory. But yeah, long intro, let's just get into it. We know that we're trying to graph some quadratics, and the most typical thing for us to see as far as an equation is to see it in standard form. Now on the test, I'm going to tell you exactly what you need to do, whether that be factor or complete the square, by telling you what form you're given and what to convert it to. So if it says that we want to convert this to factored form, which is also what is asked here, we know that we just need to factor this by finding two numbers that multiply to this and add to this. So the first thing you could be asked to do basically is factor and then graph in the standard form. We're looking for two numbers that multiply to 48 and add to 14. And those numbers are going to be 6 and 8. And we know that we use those two numbers as the two factors of my factored form. So it becomes y equals x plus 6 and x plus 8. Hopefully everyone saw with that. I meant for all these lines to be over here, so I'm still going to just do it over here. The reason we do that, the reason that's so useful, is once we have the factored form, it gives us the two x-intercepts. Okay, so we take the two numbers that we see and we flip them. And those are the two x-intercepts. That's where we intersect the x line. So at -6 and at -8. I think it'll work. Okay, good. Okay, so those are our two x-intercepts. And remember that the last point that we need to draw is the vertex. We have our two x-intercepts, but this is where logic comes into play. We know that the vertex has to be exactly in between my 2 points. So in this case, that's pretty easy. We'll see for the next example how that could be harder. But the vertex has to be on this line, or when x is equal to -7. So if it asks you when or what the axis of symmetry is, it's going to be the x value in between the 2 points. And then the last step is figure out exactly where on the line it's going to be. And remember, all we do there is we plug -7 into the equation to find the vertex. And And I'm not going to make it too difficult on the test. The fractions will probably be extra credit, but it's going to be -1. So -7, -1. You might notice the pattern. And once we have those points, no need to plug into the equation at all. Just draw up from there. So again, that's why we like to factor. Graphing in the factored form is insanely easy. So yeah, that's the easiest it could be. We're now going to talk about example 2, which is also factoring. And what can be trickier is figuring out the vertex in a non-perfect example. So here, again, we have the standard form. And we want to graph it by factoring, okay? So the problem here is it's way harder to factor when we have like a leading number, right? If we have 6x squared plus 5x minus 6, the factoring is harder. So the way that you have to do this, remember, is multiply the outside numbers together, and that's going to be the number you factor. And I feel like maybe I've been a little out of the zone with this video because I'm just going through old stuff, but this is hard. If you were asked to graph this, we've never done this before until this lesson, but your first step is always the same if it says the factor, okay? And if you have that leading number, factoring becomes harder. Two numbers that multiply to -36 that add to 5, and it's going to be 9 and -4, okay? And we use those two numbers to replace the middle. Because think you're kind of going backwards from FOIL. You could do it in your head if you wanted to. This example, I think, is really hard in your head, but we're going to do it the long way. Just trying to find the two factors. So once we split up our equation, we take the first two, they share x, but then we have to figure out what number they share. And a lot of times they share this first number, right? The second number in the set, you can divide by the first number. But in this case, you can't, right? 9 divided by 6 is 1.5. It doesn't go perfectly. So we have to find a number that works instead, and that's just going to be 3, right? Because 6 divided by 3 is 2, and 9 divided by 3 is 3. So their greatest common factor, what this term and this term share, is 3x. And then on the inside, we put the leftover numbers. So 2x times 3x gives me 6x squared. 3x times 3 would give me 9x. We do the same thing over here. -4 and -6 share the number -2. And then the inside has to be the same, but you want to check your work, right? -2 times 2x, that works. And then -2 times 3 also works to give me -6. Then we take those greatest common factors and they become one of my factors. And what they have in common is the other one. So we now have the factored form, and I'm going to write this here. And before I move on, like that is something you definitely need to know, but to graph it is going to be extra credit because it's tricky. But I'm making everyone watch this because it's also pretty fascinating. The key in math is really that even when things get trickier, in this case, the x-intercepts are going to be a lot harder, you still have to do the same principles that you would have done in an easier example. So in this case, if it's trying to say find the x-intercepts, we know that it's whatever makes this equal to 0 and whatever makes this equal to 0, okay? So instead of it just being 2 and -3, we can set each of those equal to 0, and that's going to tell us the x-intercepts. And because this is new, it would only be extra credit on the test. But for a lot of the students watching, I'm trying to challenge you specifically. So I'm just solving for what would make this equal to 0 and what would make this equal to 0. So the first x-intercept is 2/3 comma 0, and the second one is -3/2 comma 0. Just because they're fractions doesn't mean we couldn't graph it immediately, right? 2/3 comma 0 isn't all the way to 1, and I'm going to zoom in reluctantly. But it's going to be like there. -3/2 is the same thing as -1.5. So the second vertex is here. Now what makes this so hard is we know that the vertex is going to be in the middle of the two of them. But if we have fractions, it's much harder to figure out what is exactly in between them. Okay? So if you ever have to find exactly halfway in between two numbers, all you have to do is add those numbers up and divide by 2. Okay? So in this case, you know, we're looking at it, it's going to be around -1/2. But we don't know exactly what it is. So we're going to add them up and divide by 2. I think just as a side example, like if I told you like what's in between 6 and 8, like the last example, you could do that by just adding those numbers up and dividing by 2, right? 6 plus 8 is 14, divided by 2 equals 7. So that's how you could have solved that if it wasn't so obvious. But when it's not so obvious, let's add them up and divide by 2. It's fractiony, so we're going to make it 6th instead. And I'm going to go a little quickly because I assume if you're watching, you know what you're doing for the most part. This is 4/6, and this is going to be 9/6. So the axis of symmetry, I said they're wrong. I had to think about it, but this is divided by 2. So it's actually going to be -5/12. And that's really difficult. So I'm going to even tell you not to watch this unless you really understand it. But in between these two values is pretty much -1/2. And if you understand the logic, that's the most important part. So it's -5/12. So this is just the hardest it could ever be if you're graphing a quadratic. We know that we have our 2 x-intercepts. And now we even know where the vertex is going to be. We just have to plug that into the equation, okay? So let's plug it in together, but just have a calculator handy. 3 times that minus 2. And then that. And if you get it, sorry, I wasn't on the screen, man. It's going to be -7.04. So a little bit lower than 7. Okay, so that's that. That's a hard question, obviously. And we're going to do one more question that's really hard next to credit with the same principle. And then we'll move on to stuff that's definitely going to be on the test. So to wrap up like the extra credit part of this, it's asking us to graph this, which we've never done before. And to do it, we want to factor. And remember that if we don't have a middle number, so there's no x here, all we have to do is make sure that this can have a square root and this can have a square root. And that's going to be the plus and the minus of the two factors, so long as there's a negative sign in between. We like to think of it as this, which is something that we could factor. Okay, so again, 9x squared, the square root of that is 3x. And then 16 is 4. So those would be the factors. I'm going to do it so quick, but the principles from the last question apply, where this is going to be difficult to graph, but not impossible. But it's going to be fractions instead. right? So the x-intercepts you could do by writing them out, but these are going to be the two x-intercepts. And what makes this question a little easier is that exactly in between these 2 points, considering they're the positive and negative of each other, the vertex is going to be at 0. Because in between these 2 points is this line. And then finally, that makes finding the vertex much easier because I just have to plug in 0 into the equation, right? Which is going to end up being -16. So I did that really quickly in case we're just for the top students. But that's how you could factor literally any quadratic, okay? Even the ones we didn't talk about. So yeah, I'll fill out the table. I did that quick because I realized it was really hard halfway through. But yeah, that's that. But we are going to now continue with 4 and 5, which are mandatory. Okay, so I'm gonna tell everyone they can skip the part we just did if they wanted to, but this is the other form that we know how to graph, the vertex form, and this could definitely be on the test. This first question is gonna be super easy because graphing in vertex form is actually easier than graphing in factored form. Just getting there is a little harder if you have to complete the square. Remember that the key to this is that if it's in this form, the number connected to x and the outside number are the vertex. You just have to flip the x number to the positive version if it's negative, or the negative if it's positive. So flip this number, and that gives you the vertex, which is 2, 5. From there, the only other thing you have to worry about is the slope of the line, or if there's an outside number at all. And since there's no outside number here, we know that the implied number is 1. If there's no number, 1 is what's implied. And we will do examples for the next 2, or the last example, where the slope isn't 1. But remember that either way, the strategy for doing this is to make a table. So if we have 2, 5, we know that we should try to figure out what it looks like to the left of the point and to the right of the point. But we know that one of these normal vertex form quadratics with a slope of 1 is going to go up 1 and then up 3. And for now, just remember that pattern because almost all the quadratics we deal with look the same, right? Up 1, up 3. This should be very familiar looking. So when I do it on my own, it takes me about a minute or less because I just find the vertex and then go up 1, up 3 from there. And then you can kind of name those points. So that's why we like vertex form. And 5 is telling us to take our standard form and convert it to vertex form. So again, read the questions. They're going to tell you what you need to do. But if we have the standard form, we either try to factor it or we try to convert to vertex form. Okay? So I'm going to tell you because it's really hard to know what to do when. So you just have to make sure you memorize the skills. So this is the completing the square skill. And the way we do that is this doesn't factor. We know the only numbers that multiply to 9 are 3 and 3 or 1 and 9. And that doesn't add up to 8. So we're going to get rid of 9 and pick a new number that will work and ignore y the whole way. The way we pick that new number that we're going to add here is by dividing the middle number first by 2 and then squaring that number to find that. Once you have this, and it's actually really easy without the leading number, you're just going to take that number and add it to the other side. So it's going to be 16 minus 9 over there, which is 7. So again, completing the square isn't that bad either. There aren't too many difficult things to do in this unit, but you just have to make sure you've mastered them all. And again, the most satisfying part by far is realizing that if you do these things correctly, it's going to give you vertex form, which is insanely easy to graph. Okay? So everything we do in this unit, the goal is convert the form to graph. And then once we have it in vertex form, the vertex is this number flipped, -4, and then this number, -7. Now, just like the last example, there is no slope. There's no number in front of our vertex area, the x plus 4 squared. And because that's true, the pattern is going to remain the same. Okay. And then this last example is going to tie everything together, and I'm really happy about it. You could even consider it like the last lesson. And again, it's asking us to convert to vertex form and then graph. So we have to convert this harder equation because we have the leading number into vertex form, but the skill is very similar. Remember that we're going to move away the 13 because it doesn't work. And then this step is where it changes a bit. We can only complete the square if it's x squared by itself. So we're going to take away the 3 from both of these numbers by dividing. Just like with factoring with a leading coefficient, think that you are going to remove the greatest common factor, the number. And finally, in this lesson, we're going to talk about why that number is so important and so cool. Once you do that, think that completing the square is going to be the exact same. If I want to figure out what to add to this, I'm going to start by finding out what it factors to, which is 4 divided by 2. The only part of this that's really hard that students will miss is that the last step is you can't just add something to one side of an equation. You have to do it to both sides. So if this side we added 4, think that we didn't actually add a 4 because that 4 is in a parenthesis being multiplied to 3, right? This is just hidden, right? This whole thing, all 3 of these terms are actually being multiplied to 3. So when you have to complete the square with the leading number, you have to multiply that leading number by that number, the number you added, and that's what you put on the other side. Then everything else is the same. And that's my equation. Now, this is really important. This is the end of the lesson. And it's going to tie together a lot of stuff. We still have vertex form that looks nearly identical, but we have a leading number, okay? It's not going to affect the vertex. The vertex is still the middle number flipped and the outside number. But that 3 is the slope, okay? And all the slope of a line does is tell you how steep it's going to go with the slope of any equation, right? So if we have a 3 here, think that my graph is going to go up 3 times as big. So just think that if you have a slope, your line is going to get way steeper, way quicker. And the shortcut we use is that instead of going up 1 for the next point, you're going to go up 3. And if you find that confusing, especially on the test, you always can plug values into the equation. But think that we went up 3, and then we're going to go up 9 from there, because we're going up 3 times as fast. So for comparing this is that example 4, vertex form with no slope. It goes up more leisurely, up 1 and then up 4. But if that slope is really big, the line is going to go up way, way quicker. So that's that. I could fill out the table, but that is the hardest it could get. I think 2 and 3 were especially difficult, but hopefully everyone felt 1, 4, 5, and 6 were doable. Alrighty, so that's the mandatory review set. There are a lot of questions for you to go through, but I think it should be easy at this point.